Audio Jungle. Audio Jungle.
This is the entire construction of the third bridge in Pingnan, the concrete-filled steel pipe arch bridge CFST, the largest span arch bridge in the world. Pingnan Third Bridge is located in Pingnan, Guangxi. It is a special bridge that crosses the Zhenjiang River on the Pingnan North Connection Road of the Liyu Expressway. Several advanced technologies have been proposed and applied in relation to the design, construction and management of the Pingnan Third Bridge. Includes integrated design and independent prefabricated construction technology to accelerate steel truss assembly for main bridge arch. Next is the active force control and displacement adjustment technology based on the Beidou Navigation Satellite System BDS. After completing the main pier with reinforced concrete and cobblestone foundation for the north side, they continue to build and perfect the pier south of the river and perform force optimization modeling for single tensioning of warped cables. Then, parts of the bridge arch are transported by waterway to the barges for lifting and installation. With the support of the cable car system connected to the two piers, the pieces of the bridge arch were quickly pulled into place with a total of 8 main arches. When parts of the bridge arch are pulled up, immediately the construction engineers proceed to screw them together. The completed bridge arch will proceed to install the bridge face right below so that the concrete can be poured on the bridge deck. With the division of the 8 main arches of the Pingnan Third Bridge, concrete should be pumped using a 4-stage continuous pumping process with vacuum assistance, for a total of 8 injections. After 13 hours of continuous construction, the concreting of the first main conduit of the third Pingnan Bridge in Guangxi has been successfully completed. Since its founding in 1928, Pot Ain has been a world leader in tower crane manufacturing, boasting over 100,000 cranes sold and installed around the world. Among them, the Pot Ain series of self-elevating cranes is the most innovative product that makes the transportation, accessibility, erection, dismantling and maintenance most efficient ever for users. Typically MDT 368 is the largest in the topless MDT line. With a maximum crane length of 246 feet, it is offered as a 13.2 USD or 17.6 USD version and is built-in, using all inverter drive motors. MDT 368 is a powerful machine that will bring more efficiency and productivity to your job site. Worthy of being the need for the widest range of activities in the market. The Belchen Tunnel is a highway tunnel in Switzerland and is part of the A2 motorway from Basel to Chiasso. The tunnel was opened in 1966 and is 3,180 meters long. To clear the mountain for the tunnel, they used the single shield TBM produced by Heronnecht specifically for the construction of the Belchen Reclamation Tunnel. It has a diameter of 13.91 m, a weight of 2,000 tons, a length of 75 m, the largest of its kind. Giant machines drill and secure up to 90 meters of tunnel per week through the complex and varied geology of the Belchen Mountains. In parallel with the use of drilled TBM single shield, concrete slabs for tunnel wall are also transported in to build the tunnel. No matter where the tunnel is opened, they will proceed with the construction. With the strong advancement of single-shield TBM, the giant machine removed about 550,000 cubic meters of stone. As the TBM moves forward, the newly dug tunnel is immediately protected by precast concrete segments to form a complete perimeter. Segments 2m wide x 350 mm thick are fed in continuous stream using a 6+1 installation pattern as the TBM progresses along its drive. The segments have been bolted into place to ensure that they will remain secure. The new tunnel runs at a distance of 40-116 m from the existing tunnels, with a height of up to 360 m of rock above. The contractor used technology from the VMT system to ensure that the tunnels are installed correctly. The outside diameter when installed is 13.52 m. With the segments in place, sealing, reinforcement and concreting were performed to ensure the integrity of the tunnel, with an intermediate sealing then fitted. They continuously learn from previous incidents and control the quality of the concrete being poured. With the original boreholes having encountered structural problems over time due to difficult geology. This knowledge was used to ensure that the new borehole would provide a long service life with only general maintenance required. This work will be completed in 2021 and then the new tunnel will be open to traffic.